Okay, in this question we're going to do a simple example involving conditional probability based on the illustration that I did in the previous video. Again, we have two dice, one red and the other white. And we're tossing these two dice. We want to know what is the probability that the white die shows a number greater than 4 given, very important, that the red die shows a 4. Okay, now the first thing to remember is that since we're throwing two dice, there's numbers 1 to 6 on each dice, so there's 6 times 6, 36 possible outcomes. So the number in the sample space will be 36. That's the total sample space. Alright, now let's identify each of the events. Alright, so we're going to say let A be the event of the white dice or die, okay, shows greater than 4. Okay. All right. We're going to let B be the event that the red die shows a 4. All right, now let's list these out. So let's look at A. Now, event A and event B. Well, event B is actually fairly easy, so let's do that one first. So the red die shows a 4, so let's put the red die as the first coordinate for the pair. So we get this. Like this, and okay, so there's B. All right, now let's look at A. Now A is the event that the white die shows greater than 4. So this is going to be the second coordinate. Okay, so greater than 4 means it can only be a 5 or a 6. So this means that the pairs would be 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, and 6, 5 for that one. And of course we would need to we'd also now need to look at what happens when 6 was the next one. So we could have a 1, 6, 2, 6, a 3, 6, 4, 6, a 5, 6, and a 6, 6. Okay, so that's A, which is the event that the white die shows greater than 4. So the white is the second one. So 5 and 6 are the only ones that will satisfy that condition. Right, so now let's look at the intersection of these two events. Right, so we're looking for common ones. Okay, so what are the common events, outcomes for these two events? All right, so let's look through here. Do we get a 4-1? No. Okay. Do we get a 4-2? No. Do we get a 4-3? No. Do we get a 4-4? No. Do we get a 4, 5? Oh, here we go, 4, 5. So we do have a 4, 5. Okay. Do we get a 5, 5? No, 4, 5. What about a 4, 6? 4, 6. Yeah, we do get a 4, 6. So we get a 4, 6. Okay, and you'll notice that's the intersection of the two. Okay. Right, let's look at the probabilities of these things. So let's look at the probability of A intersect B first off. Right, the probability of A intersect B is going to be 2 over the total sample space, so it's going to be 2 on 36. Alright, now notice that we're looking for the probability of A, which is the event the white die shows greater than 4, given that event B occurs, which is that we have a red die shows a 4. So remember that this is like so. Right, so we'd like to know what the probability of B is, of course. Well, here's B, 1, 2, 3, 4, 5, 6, so it's N of B over N of S, which is going to be 6 on 36. Right, so now we can fill this in. So this is going to be 2 on 36 divided by 6 on 36, which of course is 2 on 6, which is 1/3. So consequently, in this example, the condition that the red die shows a 4, right, didn't actually change the probability, all right, that the white die will show a number greater than 4. And the reason for that is we see that event A and B are what we call independent events. Right, it didn't matter that we had a 4 showing, all right. We had the red die showing a 4, all right. That didn't really have any influence on the white die shows a number greater than 4, okay. So therefore we call this independent events, okay. All right, so in other words, if A and B are independent events, okay, then the probability of A occurring should not be affected by whether B has occurred or not. This is what we mean by independent events. Now don't mix this up with mutually exclusive events because that's different. Alright, so that is the probability of A should in fact equal the probability that A occurs given B has occurred. So we define independence then as the probability of A is equal to the probability of A given B, or the probability of B is equal to the probability of B given A. Alright, hence what we can say is that the probability of A is equal to the probability of A intersect B over the probability of B. Or the probability of A times the probability of B is simply equal to the probability of the intersection of A and B. Right, so we have those three conditions here to determine whether events are independent. All right, probability of A is equal to the probability of A given B, or 2, probability of B is equal to the probability of B given A, or 3, the probability of A times the probability of B is equal to the probability of the intersection of A and B.